We are in University of Bridgeport, School of Engineering, Electrical Engineering Department. This is PLC lab, which provide top-of-the-art equipment that provide training for students, and after graduation from the School of Engineering in control field. All the equipment that we have in our lab was built in the lab, and this is top of the age of the technology, which provided by the big companies, and students who graduated from PLC lab, got experience working on different kind of PLC, got a job in very high-level companies in the US. This is a table tool robotic station made by IAI company, controlling by Mitsubishi PLC. This table tool robotic station can be found in different companies around the world in control systems, like pharmaceutical company, biomedical company, pick-and-place application can be used on this robotic station. Kishan is Master of Science in Electrical Engineering. He worked in this lab for 2 years, so he will explain to you in more detail and show you experiments that we do on this robotic station.
So what we have here is a system that can move on 3 axes, and whatever applications we need to run, we'll load them, and the options that we have are 99 options. So we can have a system which can run 99 different programs. Now this is called a programmable logic controller, and this is manufactured by Mitsubishi Corporation, and we have an industrial power supply on this end which gives out power to this and to the rest of the components. And all the wiring that you see here is all done according to pre-designated terminals. Now this system that is on the other side is the XYZ axis controller, and this is the one that actually moves and changes the location of the object. Now just to give you perspective, this is a single axis. So if you have movement across these axes, this is one. So if you have 2 of these, then you have 2 axes and you can move along a plane. But if you have 3 of these, you can move in space. So the program that's been put into it by one of our former students is to draw an electrical circuit, and once we start running the system, it will position itself and run the application. So let's see how it runs. Right now it's running the program according to the diagram that has been loaded into its memory. So in this application, you're seeing the robot draw an electrical diagram, and we have a pin to do that. But if you replace the pen with a cutting tool, then you can do the same thing for tool making, die cutting, or if you have a drill, you can do multiple point drilling action, or if you have a clutch, a mechanical arm, so you can do the same thing, and it will be a pick and place operation. The pharmaceutical industry, instead of a pen, if we replace this pen with a mechanical arm, so this whole setup can be redesigned to pick and place objects. So from a conveyor line, defective pills can be identified and picked out by a robotic arm. So the program that just finished this job has about 200 lines of code. The tabletop robot can also be used for facial recognition. So we'll run a facial recognition software, something like MATLAB, in conjunction with the existing system we have. Some applications would be law enforcement, security systems, and all this programming that we did has been done in-house at the University of Bridgeport PLC lab.